So we're going to start with the problem that we ended with yesterday. Cleaned off the board also. The thing I didn't do was drag the markers that are across the room and grab them.
Oh, look, we're playing Smash Bros. Today. Do you want to join us?
Hmm?
Oh, it's not him.
Well, he's not looking, obviously. You can talk louder so you can get his attention.
Do you want to play Smash Bros. With us later today?
At noon at lunch. Okay. So the end of lesson 3, which is polys, basically are polynomials. We want to be able to graph them. And to graph them, we're going to use calculus and pre-calculus techniques.
The screen's black. Or here.
We'll move it around. It was being very, very slow to load itself up. That's why I'm having you there too. By the time it does that, hopefully then I need the calculator. So open up Firefox or Chrome, whichever one you want to use. You're going to go to Meta Calculator. So we are at the step. Let me find my little mark. There we go. We're in the section labeled Extrema, which is the plural of extremes. Julian can't get the door. I forgot that part. Yeah. Which means we need to find the maximums and the minimums, the top of the hills, and how low does the little ditch go. We could just estimate. That was fine for the last lesson, but they may ask us like how high is the thing going. They are going to ask you something about identifying, is this a maximum or minimum? Our function that we were dealing with was this. Okay. X to the third minus x squared 2x. This you may already have, by the way, if you were connected yesterday. The new thing. It would be very helpful for me to be able to do the following. I know that my graph is going to have some hills, looks like a roller coaster. Okay. If I can get more of you in here in January and on, we may be doing the hands-on thing that I had the first generation of Math 3 do, which is to make a roller coaster out of pool noodles and stuff like that. They seem to enjoy the process. And it was a challenge to get them to do something like that. Well, the maximums are up here, right? Like right there. Minimums down here. Right here. At all these locations, this one I messed up, it should be sideways. Notice it's flat everywhere. The slope at all those locations is 0. So if I were able to somehow be able to identify where is the slope 0 on this thing, that would be very helpful. Well, there is a thing. It shows up in calculus. The thing is called the derivative, which is the function of the slopes. Okay. How are we going to get it, and what symbol do we use for the thing? Well, there's different symbols. One of them is to use whatever function you're using and to start using little primes right there, little dashes, to show how many times did you perform the little process. Well, we're just going to do it once for the things we need. Okay. And how do we get it? Well, it's sort of going to look like this, but just like you sort of look like your biological parents. Okay. We have some traits. Some of us look more like them than others. Okay. This goes down in the front, so we're going to have 3. There's still an x, because that's the variable we're using. We're going to subtract 1. Okay, so again, exponent goes down, and then you subtract 1, so that's 2. This one goes down there, so negative 2x minus 1, which is 1, right? Or we don't have to write it down. Then this one, well, it's already exponent 1. That would be helpful to know in the first place. 1 times that is negative 2. 1 minus 1 is 0. Anything to the 0 power, remember that this is 0, so that goes away, just to clarify. Let's rewrite it. So our derivative is this polynomial. If we plug numbers into here, we're going to know what's the slope at that specific location. We only specifically care about when the slope is 0, because that means the thing is flat. It means that we're at the top or we're at the bottom. Okay, so we're going to set this equal to 0 like we've been doing. And then we have 2 options. I'm going to peek down here to see which option works. From my notes, I noticed that I crossed off an x right there, noticing that Oh, x isn't going to help us this time. Meaning we have to do the quadratic formula because the answer is going to be decimals. Okay. This is where our calculator and why Jasmine is going to assist us, and then I'm just going to tilt it over to the smart board. That way it's not going to lag over here. Okay, so the quadratic formula, we have a variable equal to negative b plus or minus, so negative boy couldn't decide if he wanted to go to the radical party. The boy starts with b, is squared. He lost out on 4. Awesome. Chicks AC. And the whole party was over at 2 a.m. So we have a bunch of blanks. This format, I don't think on your units there. Writing it this way because I think it might be helpful, especially if you previous math levels yet you didn't get a whole lot of practice on this. This is how they're showing it this year on Edmentum for the Math 2 people. May be helpful because I know that all of you connected in your class, the Math 2, I'm not quite sure if they are understanding this. We're just putting numbers in here, and it should be a rather quick process. Where do we get the numbers from? Well, you notice me mentioning words that start with A, B, and C. A is that, B is -2, and C is -2 as well. And one way to also remember where the letters go, it's going to be B, B, A, C, and A on the bottom. Those are what the blanks are, by the way. There's always that 4 there. There's always the 2 on the bottom, a little 2 on the top. Okay. For the next problem, I'll write out the formula also in case you haven't written it down recently. So B is -2. So this is -2. This is -2. AC, 3, -2. Over at 2 a.m., 2 times 3. Okay, I'm going to go to another board. On there, you're going to see me negative times negative is positive. So +2. Down here, it's 6. What I need you to do, I would recommend MetaCalculator. That way you see it the same way that Jasmine's going to do it on the smart board or whatever calculator you want to use. You need to enter all of this stuff right here. For the problems we're doing, you should not get a negative answer. We did those already in the previous unit where we were practicing stuff with I. Yeah, some problems are like that, but not the ones we're doing. So type all of that stuff as seen right there into a calculator. Jasmine is doing the same thing right now.
I think this is square root, right?
Yeah, that's square root. Okay. Oh, don't put the square root. See, so just type the inside. If you have already pressed the square root, don't jump the gun. Because we want to double check that we're actually typing the inside correctly.
Oh, yeah. So
take that off. So just type the inside. You're typing parentheses, -2. Make sure you have parentheses there. If not, you're going to get the wrong answer. Okay. Once she has something typed, I'll put in that. Julian, focus and write whatever is on the board. By the way, if you're using MetaCalculator, I wasn't looking to see what she did specifically for the x squared. You may want to, never mind, not x squared. When we have to in the future to type of x squared, you want to use the button. It's not programmed correctly for some reason. I'm going to switch it now so you can see what she is doing.
And then do you want me to just click on those three buttons?
No, so just press equals. Wait. Oh, that's why. You don't want to be on the graphing calculator. So go back to the home. You may want to copy and paste what you have right there. That would be. Just going to copy it. Usually we are on the blue section. Just go scientific calculator. That would be helpful. Because there's no regular equal sign on the blue section. I'm going to get the camera on the spot. She's going to paste. Take off the equals in case it doesn't like it at the beginning, which okay. Notice you should get 28. So you type all this stuff, you get 28 inside the square root. And this is just showing you, if you go to MetaCalculator, the green is for typing stuff like this. The blue is, I need to use the variable x somewhere in my typing. You put it there. So let's continue with that calculation. Okay, so x is equal to negative times -2, +2, plus or minus the square root of 28, which on other sections we would do some reducing and stuff. I don't care about that right now. I literally want to know where do I put the points. Okay, I want to know where is that little hill located. This represents two different values. One of them is when you add them. You're going to add the square root of 28, which is some decimal. The other time is when you're going to subtract it. So the next calculator thing, and again, just to make sure, is going to be, I would type the top, or you're going to put parentheses around if you want to do it in one shot. I don't know which one Jasmine is going to select to do. Either when I was on my phone, I was doing 2 plus square root of 28, I press equals, and I would do divided by 6. Either way is fine, or you can put the parentheses.
You keep using the mouse
Oh.
instead. And then square root, for that one, do I just click this one?
Yeah.
And then
Close,
should I close that
yeah,
out?
close the parentheses, and you're going to do 2, one more to right parenthesis.
One more right parentheses?
Yeah, one was for the 28, one's for the, to show it's the top thing.
There you go.
Okay, and then press divided by 6, because I don't really care about that 7 number. I care about what it is when I divide it by 6. Okay, and it's 1.2. We don't have to be that accurate, so it's 1.2. We're going to do the same thing. And notice if you're on this online thing, or you have a graphing calculator, she can just go over and click and change the plus to a minus. That's a quick fix. Before she does that, let me remember to take 1.2. And that was an X.
Wait, let me.
Yeah, just change the plus to a minus. Okay, now it's negative 0.5. Okay, we have x's. What we don't have are y's. So we need to plug that into our function. Not the one with the prime, the new brand new derivative thing, the little dash thing. We need to go back to the original and plug it in there. So to show you what we're going to do next, let's do that in blue. That would be me doing f of 1.2. What does that mean? This line further this way. That means I'm going to end up doing 1.2 to the third power. Move this over.
Wait, do you want to write that down?
Click over to the blue one. You're going to use the blue now. So you could type this out in that, but I want to show you a certain technique that may be quicker in the future. 1.2 minus 1.2 to the second power minus 2. So either you're putting all of this in the calculator, which is perfectly fine, or Jasmine typed that equation that's up there in blue. You're putting y equals, type the original equation. So again, you have two options. You either type all this in the calculator, or you're putting into the graphing calculator part. So the one that's x to the third.
Oh, that one.
The our original polynomial. You go to graphing calculator. You put y equals, that's the same thing as f of x.
Like that?
Minus.
Oh.
No, you did it fine.
Oh, okay.
X to the third minus x squared minus 2x. This is appropriate use of technology. This is what it's for. Okay, you're going to click on table. Okay, and then press yes. You double check that you typed your thing right. Okay, go up right here. Click on start at, and I want you to type 1.2. Notice it says 1.2 right there. Our y value is negative 2.1. So I'm going to write that over here. So y is equal to negative 2.1. The other one was negative 0.5, I believe.
Yeah.
You didn't forget. So now instead of retyping stuff, she just needs to change it right there. Just change that to negative 0.5 and it'll show up on the table. You messed up. Oh, yeah.
Wait,
Fine.
that's
There you go.
That's fine.
Notice 0.6. Okay. And just so that you can see the numbers next to the original x's that we got off of the quadratic formula. Okay, these two go together. To remind you what that looks like in coordinate form, that's this. This other one would be negative 0.5. Right now, some of you may be able to tell if you think about it for a little bit, which one's the maximum, which one's the minimum. Some of you may not. Remember that we already have from yesterday, we have I think it was 3 zeros waiting for us in our notes. I'll remind you what they are. We also already did the limit stuff, so we know about what it's doing all the way to the right and what it's doing all the way to the left. Okay? So now let's sketch out.
Oh, that's a 5 for the fly.
For which?
Oh, wait.
I did it right.
Oh, wait. No, I think you're right.
This one's right. Yeah. Stop confusing me. I didn't mess up that. So we're going to make ourselves a big, nice graph. This is about half a piece of paper, by the way, one side. Let me grab my notes. I can see those. I don't know off the top of my head what the zeros were. From yesterday, our zeros were 0. Just by chance, 0 was one of the zeros. We also had 2. So this is a spot where it crosses the x-axis. X-intercept, zeros, roots, those are all the same thing. Just a different way of saying it. -2, here's another one. So I know crosses at those 3 spots. Yesterday we did the limits. That's to find the end behavior. Went all the way to the right. So over here, I know that it does this. It points up on the right side. Again, this is your right side. For those of you who can't keep it straight. And all the way to the left, it's going to point down. So it's going to point down and up to the left. I'm not necessarily going to use this little piece of the arrow. This is just to remind me when I orient. So I know that it's down below this one. That means if this is higher, it's going to go down. It's going to curve up and go like that. What we did this morning so far is to figure out how high is the little hill and how low do you go. Well, let's graph those. 1.2. Okay, if this is 1.2 is like around there. And then -2.1. That's 2, so -2.1. We have a point right there. And then we have -0.5. Okay, that's half. -0.5 and 0.6. 1, 2, so 5, a little bit more. 0.6. Let me move this because it's awkward. So that thing is -0.5. Okay, now I know how high I go. And you can decide. Let me just double check things. Things are a little bit weird because obviously I'm not using graph paper. And again, for the next part and actually drawing the graph, use the pencil. I have something that I can erase. Okay, so let me clean this up. And notice on the edges, it's pointing the same way down on the left, up on the right. I was able to get it through the 3 spots. Oh, this one I messed up a little bit, so I'm going to clean it up. Probably because I didn't scale things correctly. Yeah, because this gap is smaller than this one. That's why it looks weird. But this is the top of the hill, the bottom of the hill. And this is the graph of our polynomial. Okay? We're going to go through the process again for one more. And then we'll go to lesson 4. Scientific, yeah, because we're going to need the quadratic formula. By the way, one thing I was noticing as I was looking through my notebook for stuff from yesterday and things I wrote last night is that there's another abbreviation. I like giving you acronyms. They help your brain to remember things, just like whoever the teacher was who brought up the term PEMDAS at some point in your life. Okay, that those words mean things. You may have to stop and think about, okay, what was the E for again? You know what most of those letters mean and probably how to use them. Okay, our steps when we're graphing, if we want to graph a polynomial and actually using all the different pre-calculus steps that I have introduced this week to you, well, our steps spell out the following. Oh, I'm going to show you a picture of somebody. Oh, the one who maybe would know who the person is, he's happened to step out. We'll test him when he comes back. Where'd it go? I know I searched for it. Oh, let me do it again. I had it already, but... So there's a famous person. There was a movie a couple years before the pandemic started where this person was portrayed. Let's see if any of you know who this is. He was famous and alive, because I believe he's no longer alive, when I was little, in elementary school. Anybody of you know who this person is?
Is it a baseball player?
No, he has a baseball hat. So I'll go show Jasmine. Oh.
Yeah, because I was looking at your camera.
Do you know who that is?
It looks so familiar.
And there was a movie,
Oh.
which is the basis of why people have lots of shirts that say straight out of different things. Yes, that's Easy E. Straight up
Straight out of the hood?
out of Compton.
Oh, straight out.
And then you got straight out of SAC, and then straight out of like different things for different jobs. I think I saw nurses saying straight out of the ER. One of them had a little pin when my dad was there the other day. Our steps are going to basically spell out the way that his name sounds. We have an E step, which is end behavior. We have our Z for zeros. And we have an E, which is the thing you saw them with the Extrema, Easy E. If you remember those, you know what are the three things Rodrigo sort of wants to see. And if you do most of them, I'm going to give you the credit. If you forget like one little thing out of all of them, okay, but you're able to get yourself to an answer, okay, you got most of the things, okay? If you're actually able to do all the things I'm going to show you right now, then you're going to get some bonus points. So make sure you upload all those things. Okay, next, polynomial. And I'm going to go quickly because I do want you to see most of the things for the last lesson today. Why? Because tomorrow is when the test starts being available to some of you. Some of you, I think, hopefully some of you, I saw the names for some people in math too, were uploading things that they should have done before, and they're left unit 4. Hopefully you guys were doing the same. Okay, here's my polynomial. And I don't want to just guess and do a table and stuff like that. I could do that. It's helpful for some things. But we're going to do Easy E, okay? Those steps. The first E is for end behavior. How do I show that I'm doing that? That's when you do the limit, okay, of stuff. Okay, so the limit of x, as we're going to the right side, because that's where the positives are. This is the right side of what? Of our line leader. And it seems like it's always x to the third. That's because we want to use the quadratic formula. Obviously, there's polynomials with bigger ones, but that's why you have to for you to do some calculus. The third, that means if I'm going to the right side, I'm talking about positive big numbers. So an example of a positive big number is 1,000 to the third power. I don't care about the specific number. I care about what type of a thing would that be. Well, that's a positive big number, meaning on the right side, it's going to point up when I'm on the right side, okay, like last time. Some of you even may know by memory what it would be to get some of the points, because especially if like this isn't clicking, if you remember, it's odd. I know one of them points up, one of them points down. That's good enough for me. If you do this, that's showing, okay, this is clicking. I want some more points. Let's bring up my average. As I'm going to the left side, the limit, so me thinking I'm riding that roller coaster, I'm going backwards, I'm hitting rewind. What's happening back there? Well, that's a negative big number. Like what? Like negative 1,000. Okay, if you carefully put that into the calculator with parentheses, without parentheses, sometimes you're going to get the wrong answer, depending what the exponent is. You'd get a negative big number. That tells us, it's just like the last one, it's going to point down as I go to the left side. Okay, check. I did the first E of Easy E. Now I'm going to do the zeros. And I could, at this point, put these little arrows on the edges of my graph. I'm just going to wait for the end. Okay, I'll erase the board. We'll catch up. On the first E step, put in the chat 2 stars. I get how to do that part. I understand that part. Either I know how to do that limit stuff that you're showing. It sort of makes sense to me. Or I know that the odds point in opposite directions, and I know that the evens point in the same direction. 2 stars, 1 star, question mark, 2 question marks. How is it for you at this moment? Okay, whatever it may be.
The answer would be on the calculator instead.
That's fine, as long as I can see something. And the 2 voting, I got more than 2 of you here, so the rest of you. The Z is for zeros. Whenever possible, you want to factor because the process is slightly shorter. If not, then we go to the quadratic formula. As promised, this is the next problem. To remind you what that looks like, last time I wrote it just with blanks. Negative b plus or minus the square root of b squared minus 4ac over 2a. This is the thing where I keep on saying negative boy. Okay? I know it's going to work out that way. So that we can see it, I'm going to rewrite the function right here. Since you have it on the same paper, you probably don't need to, unless you're on the back side of the paper. Okay? Here is a. Be careful with the negatives. B has this negative with it. And C is that. Okay? So I'm going to go x equals. I'm just going to put the blanks just to make sure I have my setup correctly. I'm taking off the letters, leaving the numbers that are always there. That exponent 2, the 4, and the 2 on the bottom. Okay? Then I'm going to start plugging things in. Well, the b's go here. That's negative 10. Then it's the other two numbers. A is 1. 1, 9, 1. Okay. 2 times 1 on the bottom. Oh, we know that's 2. Negative 1 times negative 10 is positive 10. Why we need our calculator? In my case, why I need Jasmine? She's going to type in all this stuff that's on the inside. Last time it was 28. What is it going to be this time? Okay, you should be typing this in to see if you can match her up. Because if you're having a lot of issues matching it up, that's one thing to focus on, your accuracy. Okay. So again, she's typing in the thing. And now she was cussing at us as a cartoon.
You're so funny. What?
Well, hopefully she doesn't make these mistakes at lunch during Smash
High five. Yeah. Sure.
Okay, so we should get 64. Okay, so 64 is in the parentheses. Need someone to tell me what's the square root of 64.
8.
Okay, good. Notice this is one of the reasons why it helps you practice. That some of these answers you know. Okay, so 10 plus or minus the square root. Oh wait, we already know the answer. 8. So one time I'm going to add, one time I will be subtracting. We don't need this stuff anymore. Okay, so we're going to do 10 plus 8, and I'm going to use a whole lot of room, divided by 2. So Jasmine's going to put that in the calculator. Parentheses around the top if you want to do it in one shot. If not, you're going to do 10 plus 8, press equals, or you can do it in your head, which most of you can handle, and divide it by 2. The other time you're going to do 10 minus 8, get that answer, and divide it by 2. These are our two different x's, or two different zeros. Oh, I just noticed I skipped a step on something. None of you told me. But it's going to work. It would work out the same way.
So I got 9 for this one.
This one's 9? Okay.
Yep. And then the other one is like 2 over 2, but simplify that and you get 1. I did that
1? Okay. I want to point out something, and none of you told me. This is me going way too fast. This is the quadratic formula. Notice what our exponent is. It's to the third. Okay. So something's a little bit off on this one, and I think I forgot an x here as well. Okay. This was our original function. Notice that they all have x's. If I want to use the quadratic formula, the biggest exponent should be 2. But this is accomplished by dividing each of them by x. Okay, let's do some factoring. This should have been done before, but whenever you notice your mistake, then you can fix it. Okay, so we're factoring. Okay, so when I'm factoring, I'm going to get x on the outside. I'm going to get x squared. This is why I didn't tell you erase the whole thing, because what we did is technically right. We just did it too soon. We did it without knowing that it would be fine. Okay, because notice A is still 1, B is still negative 10, and C is still 9. That's what we just did, right? But now we are allowed to do it. Sort of like how some people start driving before they have the license, and then they have the license and they continue driving. Okay? A, B, and C, that's still these answers that Jasmine has. But now I have this extra answer out here, because remember, we're setting this equal to 0. When we split things up, x equals 0. And we already have our answers of 9 and 1, according to Jasmine. Notice that the other one, right here, well, notice that's 3 things. Today we haven't tried the factoring. When I wrote the z step on the other board, I put zeros. We should try factoring first. Notice if I would have done this, I would have noticed, well, 1 times 9, and I put negatives right here. Once I set up my equations, and notice I'm not taking out my calculator right now. I'm not asking Jasmine to do anything on the calculator. I split it up into 2 equations. And these steps should seem very familiar, and hopefully you're saying to yourself, oh, I could have done that. Notice these are the same 2 numbers that Jasmine just told me with the quadratic formula. Either one is fine right now. Before, when we were doing the factoring section, yes, I need you to do this because it's about factoring. But now you have options. Whichever way you want to do quadratic formula every single time, go ahead. That's why you need to be accurate with your calculator. 1 and 9, 1 and 9. Okay. Now what we're going to do, Jasmine, click over to the blue one, the graphing one. We're going to replace these x's up here. We're going to plug in 9, 9, 9, 9, and then we're going to put 1, 1, 1. Okay, so she's typing this green equation into the graphing calculator. Why? Because I know one of the points is 9 comma something. The other one is 1 comma something. Oh, wait. Let me see. Let me pause for a second. I'm getting ahead of myself. Okay. Okay. My question is, does Jasmine need to plug it in?
No.
Why not?
Because in the table we already have our x values.
Okay. We did this section, right? The first one, and behavior. What does Z stand for? Z, well, like there's not many math words start with the Z. Some of your ancestors invented a certain number.
0.
Okay. Okay, the zeros tell us that at something, comma 0, these are the zeros, right? What they look like. Well, we just found the x's. Jasmine found out on the calculator. We know that one time it's 9 and one time it's 1. Oh, so this is a 0. No calculators needed. So we have 1 point that's going to go on the graph. Second point that goes on the graph. It says x equals 0. That means that this one is 0, comma 0. Okay, now we have our 3 zeros. We also know that on the left side it points down, on the right side it points up. Okay? Now we have our last e to do, so we did this one. We paused for a second. We got ahead of ourselves and forgot to factor things. The last one, the new thing that we were looking at, which is the derivative, the thing where I want to find where is the top of the hill, where is the bottom. That's when we actually need to use the graphing calculator because we're going to get some weird decimals. Okay. So our original function, which you're writing down for the 3rd time, I believe, x to the 3rd minus 10x squared plus 9x. We're going to do a pattern that you've seen maybe just once. I may have at some point very early in the school year have introduced to you the fact that this little pattern is supposed to just some calculus. And most of you may have had a surprise look. We take the top, we throw it down in the front, 3x. What do I do to the exponent? What did I do last time?
You subtract it with 1.
Yeah, subtract it by 1. Use one of the ones on the top, subtract by 1 squared. This times that. 2 times negative 10 is negative 20. Subtract 1, that's just x. This is exponent 1, so it's 1 times 9 is just 9. 1 minus 1 is 0, so this goes away. So this is the answer. To know where the things are flat, that means it's 0. When you flatline, 0 activity, unfortunately. Okay, we could check to see if this is factorable. I'm going to look down on my notes to see, was it factorable? No, it was not. So that means we need to do the quadratic formula again. It's okay to do that because a quadratic has the biggest exponent of 2. So our blanks, the negative boy couldn't decide if he wanted to go to the radical party. The boy was squared and lost out on 4. Awesome. Chicas also starts with C. Okay. That could work. Chicks, anything starts with C can go over there. 4 awesome cats. Went to a cat cafe. Okay. Originally they're going to open one on Capitol Avenue. I saw in the news some girl wanted to do that. 2 a.m. Let's put our numbers. This is A. B is the negative 20. C is that. So negative 20, negative 20, 3, 9, 3. Negative 1 times that is 20. Plus or minus, calculator time again, with what? With all of this. In this lesson, you should get a positive. If you're still doing Unit 3 stuff, you could get negatives in there, and then I need to show up. So that's what Jasmine is going to be doing over there. Back on the green scientific for me, please. So type in that stuff, some kind of positive number. Should be a 3-digit number if I did it right yesterday.
I'll just paste it over there.
$292. Good, that's what I got last time. So we're going to do 20 plus square root of 292 over 6, and 20 minus square root 292 over 6. 20 plus square root 292 over 6. Obviously, you're noticing that the process is long. This is why there are apps, like for example, if any of you watch The Big Bang Theory, now on just reruns, there's some math thing that I don't even know what it is. I sort of vaguely know what they're talking about that they need to do. Evidently for physicists and engineers, they do it a lot. It's a very long process, similar to this. So in one episode, they decided to design an app where you just plug in like the A's, B's, and C's, and then it'll give you the answer. That's how some of those things that we at times use to check our work, how those work. At your level, you want to be able to see, can I do the whole process? Because the skills are useful for other things. And again, we're going to go like that, to save time, because I haven't been written down over here. This one is 618. This one is 49 cents. If you plug these numbers in for all those x's on that f of x that you've written down 3 times, I'm going to write it down again. The corresponding y would be negative 90.28, which is way down there. So this is probably the minimum. And then the y for this one is 213. So let's sketch our graph, because we do want to do at least, 15 minutes of the other one. We'll see what we get done. The last lesson, by the way, isn't as long as this thing. Okay? This is your super long one. Okay, let's put our zeros. Let me look back at my notes since I have erased it from the board. We have a 0 at 0. We have one at 1, and we have one at 9. Okay, there are 3 points. We also know that on the right side it goes up. On the right side, right? On the left side it goes down, because it's a regular or odd function. That's what odd functions do when there's no negatives in the front. Okay, and then we're going to add these points. So 6, 6 is around 6.18 around there. Negative 90 is way down here. Somewhere just put it. It doesn't have to be drawn to scale. So that means that around right there, there's a dot. Probably it's the minimum. And then the other one is a half, which is around right here. 0.49. 213, 1, little 2, 213. Just right here. And now we're going to draw it out. Okay, so let me make sure this one is not lined up where it should be, because it should be above that line. That's why it looked weird right there. Okay, looks a little bit better, makes more sense. Okay, because it has to go up, and then it has to go down, and then it's going to go down like that. If it's going down like a slide, and it has to hit that point that's way down here, it's going to go like that, big old dip, and then it goes back up. Okay, that's our polynomial. So after seeing all of the the easy E steps, put in the chat 2 stars. I totally get every single step. If you do, wonderful. 1 star, I get a lot of the things. I think I'll be able to show you most of the things to make you happy, and then I actually will get to the identifying the right graph. Okay, question mark. There's something that's blocking me. I think I may not be able to get to the answer. 2 question marks. I've totally lost all the things you just said. Where are you at right now? Write it on your paper right there. ¿Dónde estás? Jasmine put it up there, and then let's get a vote. Was it? This is 943. So new votes. That vote from Gemma's from before. Where are you at with polynomials, grafting, and show me all these nice steps? Because we're going to take it back a level. We're going to back out of the pre-calculus, calculus world for a bit, back into just some advanced algebra. So Gemma, Isabel, Scott, Angelina, probably technical difficulties. The thing should be uploaded. I should have it before I leave today on YouTube and stuff, so you can watch whatever you missed. Where are you guys at? And again, more important for you guys than for me. Make sure you're writing down those stars and stuff so you can use your metacognition skills and think about your thinking, your learning. Okay, now for lesson 4. In lesson 4, we're going to see what function should I use? Because on these, well, they give you f of x. On lesson 4, make sure. Which function? For example, you get to choose from the following: the cube root function, the square root function. Again, cube root looks like that. Square root, you know what that is. Okay, an exponential, which looks something like y equals 2 to the x. The x is up there. And then step function, which I'm not going to give you an example of, and it's not that, by the way. They're just throwing it out there because one is not like the other, as Sesame Street says. Okay. So now let's give you an example, and we're going to form a function. So there's this girl named Chloe. She happens to be a pharmacist. What does she want? Well, they need bottles. She wants the height of the medical bottle. She wants to know the height. Okay, so I'm circling this. This is the important variable of all the variables that will be showing up. Okay, she got some info from the supplier. Okay, from the supplier. So whoever makes the thing or is the one who ships it to the pharmacy. The supplier told her the following. Told her that the radius of the medical bottle is 1/4 its height. Okay, 1/4 its height. But Chloe also knows some stuff about the bottle, or how the bottle should be. What does she know? Well, she knows that the bottle, the following is not a standard symbol, but it's one thing I use. I like using this symbol for has, or you can just write out has a volume equal to V inches cubed. It's cubed because it's in 3D. That's how much space. Okay, so again, to illustrate, what are we talking about? Well, just like most medical bottles, so we're talking about the bottle without the cap, by the way. So this, or like this, like you need your medicine from Rite Aid, Walgreens, or wherever you go, CVS. Okay. The radius is up here. The height is right there. The space inside, that's the volume, right? Okay. And if I look at it from the top, here's the circle on the top. Well, the radius, and they told me that the radius is 1/4 h. Okay. This is the base. Okay. When you're doing geometry stuff, which is slightly seasoning your unit with a little bit of geometry, capital B stands for base area. Okay? Base area. And you see it in formulas, because you're going to see it in a formula right now that some of you have seen, some of you may not have seen. Those of you who took the STAR RAM at some point this school year, we're all going to take it at some point when We're back in January. I think it's towards the end of the month, just to see where you're at. You guys, since you have been doing math, should score pretty high. Most of you should be in the green level, by the way. That's usually what happens with most of the Math 3 people. Even if you're not the awesomest at stuff in the class, things sort of click on there like, oh, I can get the answers. Okay. To do the volume of something like this, you do the volume is the base area times the height. Okay. Well, what's the area of a circle? Isn't that area equals pi r squared? So I'm going to put that where b is. So pi r squared, that's the b. Height is right there. On all these formulas, I want to get to only have like one letter on each side. Okay. Well, I know that the r from the other picture, just putting it so I don't have to flip the camera, is 1/4 of h. So this r should change to the following. So r is 1/4 h squared times that. Well, I need to square everything inside. That, the bottom gets squared, and that. 1 squared is 1. 4 squared is 16. I got h squared. Julian, pay attention to taking pictures of paper. Okay. When I put this all together, what do I get? Let's see. This goes on the top because it's like this, pi over 16 times h to the third power. What letter did I circle on the other board?
You circled H.
I circled h because that's what Chloe wants. She wants to know the height. She doesn't want them too tall or too short because not the pills are not going to fit inside. Okay. So we need to solve this thing. Notice from our three choices, because I told you it's not the step function, exponential, square root, or cube root. How do I say h to the third power in a different way?
H cubed.
H cubed. Notice you said cubed. One of our choices says cubed. So sooner or later, what I'm going to do, it's not my first step, to remind you of the steps. 16 over pi. 16 over pi. If you can already identify, because you got to this step, you can identify which one it is. Oh, the one that models the situation is the cube root. Okay. Why? Because I'm going to get 16b over pi times equals h to the third, which to solve that, I need to do the cube root. Just like I have a square root tree, well, here's another tree, the cube root tree. Okay. Notice if the cube root showed up, here's one of our options. H is equal to, and you don't, for these types of problems, you don't need to know this. I don't need to know the specific equation. I just need to know what type of formula we're going to get. It's a cube root. Okay. Well, the square root is with 2. That's why those of you with iPhones like Julian, when I was using his calculator that one day, I saw the little 2 on there. And I'm like, why is there a little 2? They think we're too slow, that we don't know that? Okay. I think so. I don't know. Some iPhones that I've seen, does it have a little 2 on the square root? Yeah, it does. It has a little 2. Okay. Let's go on to the next situation. Now we are homeowners. Hopefully you will get to that. Because evidently from our 2 generations, that's a hard thing. Okay, so my nephew being a new homeowner who's fixing up his house, he should have got one where he can just walk in, but evidently my nephew likes doing things the hard way. Okay, millennials and you guys, Gen Z people, that's a hard thing, so you need to be as prepared as possible to be able to do that thing. Because the numbers show that not too many of us of our generations are able to do that. Number 2, we are homeowners. Owners who need to make a fence. My nephew had to make the fence. He's going to help, him and his brother are going to help me in my grandma's backyard to make a fence also after we took off get some roots taken out of there, some tree trunks. But for some reason, this person wants to be all exotic and make a triangular fence. I've never seen anybody with a triangular fence, but whatever. Triangular fence, and this is in the backyard, okay? And they give us a description. It says 2 sides. This is the one that I didn't reload with ink. Of the backyard are perpendicular. All right, but that means it's making a right angle, okay? Perpendicular. It tells us one of these, one side is equal to m feet. The other perpendicular one equals n feet. As you can get the point, this was in a big old paragraph. And notice this is me chunking out. You had it in print, you'd be like circling stuff, is writing down the key points. When you do the same thing, you don't have to organize it my way. You organize it whatever is going to click for you, as long as you can form a thing. If it's talking about a shape, let's talk about a shape. I told you, so it's two sides, right? We know it's a triangle. Okay, so it doesn't go like that, okay? That's not going to work. Okay, it's going to go, it's making a right angle. Okay, there's two of them. Oh, it goes like that. Obviously, the triangle can be turned around, but at some point, it's going to look like this. One of the sides has m, one of them has n. And the third side is, this is a cursive L feet. Because if I just put it like that, you're going to say it's 1. So we have to, so that's the cursive L, or you can put a capital L if you want. You're not going to be able to handle that one. Okay, so L feet, we have that thing. Do any of you remember a formula that goes with this shape? It's like one of the first formulas you ever learned.
I was gonna say
That's another something like that is another one. The other equation that may come to mind, because the first thing came to mind, like, wait, how are we going to do this one? Because this one is not as specific as the other one. It doesn't tell us what they're looking for.
Something with 1/2.
Yeah, this is one that came to mind. This would be harder to be able to prove which of the three choices it is. What's the other one? Like when you were in kindergarten or before, if your parents prepared you, kind of thing, or if they just let you be a little kid, that's fine. That's like how mine were. I don't think I knew my. What's the little song you learn with the 26 different symbols we use for reading and writing? You learned your something something something. Okay. It's not clicking. Like even Rocio said, like if I need to alphabetize something, like I always have to sing the little songs to remind myself where all the letters go. What are your letters are called what are the first three letters of the alphabet?
ABC.
Yeah, your ABCs. What's the formula with the ABCs?
A squared plus B squared plus C squared.
Okay.
What though?
Equals C squared.
Oh,
Okay. Notice you just said squared. Our three choices, one was the cube root, square root, or exponential. Which of those choices do you think this one? Okay, so this one's going to be the square root. We could prove it. We don't have to. I already said square. It can't be the cube. How's it going to change into 3? Okay. As long as if you made the picture and you're like, I know formulas for that thing. Square root. Either people are having lots of. You guys aren't watching, but I only have Cam over here for some reason. Connected. Don't know what happened with everybody else, but Cam's getting what she's getting out of her thing, and I know she's on top of the math things. I want to show you some, for the last part, I'm going to skip some things. Little graphing review of certain things. We've been mentioning the square root function and the cube root function. We should probably know what they look like if we were to go to a graphing calculator. We're not going to do it on there. We can sketch it for ourselves. So first, let's work our way up to the square root function. So those of you who are actually writing, a new side of the piece of paper. So this is graphing review. Okay, you should know by now, hopefully. I think there's a more probable that you'll know rather than maybe Math 2, I don't know. The x squared looks like this, right? That should make sense to you guys. It's parabola. Some of you may even know that y equals negative x squared is the same thing, but flipped upside down. Okay. I don't think those are too shocking for you that this one goes down because it has a negative in the front. That one's up because it's positive. Because I think I mentioned to both of my math classes this year, smiley face, frowny face kind of thing. Okay. What happens if I switch the letters around? If I go like this.
Why did it go like a little loop or something? Like don't make like a weird shape.
Well, the equations look almost the same, right? And we've been learning this unit. We kept on talking about odd functions and even functions and all that. So we know that the exponents determine the shape. So still parabola, but the question is, what's the difference? This is when you're awake. You're like, It's going good. It's not going too good. Okay. Hopefully last night, hopefully earlier than me. Lately it's been like almost 2 in the morning when I finished lesson planning and getting ready for the next day. Well, you have to go to sleep, right? And for most of us, we're lucky enough to have a place to lay down, right? So the parabola is going to be sleeping. That's the term it's called. It's on its side. This is a sleeping parabola. Notice this is positive, right? This is the positive side. That's why it's facing that way. It likes being on that side of the bed. Okay. This sleeping parabola faces the other way. It goes this way. Why? Because this is the negative side. Notice that as a negative. Okay. Also sleeping parabola. However, I want to point out something. What would happen? Because like on graphing calculator, most of them, some of the online ones actually will let you type this in, like Desmos will. I don't know if that when Jasmine was doing will. Most of them won't y equals, like on Jasmine's handheld graphing calculator, the one that's in the table in front of Julian. You have to change it to y equals. Y equals. And we've been learning that just like on the quadratic formula, they have that plus minus. You have a positive answer and a negative answer. Okay, it's going to be like that. If you do this one, where are you going to take the square root? Here, there's a little bit more solving involved, meaning let's divide by -1, and then, wait, do I want to divide by -1
Maybe
first?
like x. No, because the y is going to be positive.
Let me see how I want to do this one. Well, I think it would be that. So, okay, we're going to get -x equals, this bottom orange one, by the way, usually we don't deal with. Okay, go like that, like this. Technically, it'd be like this, but I'm thinking about that negative. I'm like, wouldn't that mean that you're going to have eyes up? Something like that. But basically, the key point here is that there are two pieces, the positive and the negative piece. Hopefully, you know that the positive piece is the one on top. The negative piece is the one on the bottom. Okay? So, last thing for today, since we're only going to get to the square root thing, we'll do more tomorrow. If you guys are ready, I'll open up the test for those who are ready. If not, we'll keep on going. Remember, you're still connecting. Friday should be your testing time, and I'll try to choose problems so that it takes up like an hour, hour and a half, not like 4 hours. Okay? Because technically, I don't know how many problems they decided to put on the next one. So if I want to do y equals the square root of x, the positive one, the graph, this, where did this come from? It came from this, right? The positive one, the positive sleeping parabola, is just the positive piece up here. It starts right here and it goes like that. Well, where's it? It's other kid. Well, this guy's other kid is the negative one, the one where things aren't going well from. What does that look like? Well, that's the bottom part. That's this one. Okay. If we were to need to graph a sleeping parabola on regular graphing calculators, you have to type this in one and this in the other, and then you get both pieces together. We'll show you, the two siblings, the two kids that belong to that thing, the sleeping parabola. But this is what we're going to be doing and moving it to the right, moving it up a little bit. We're not doing too much with it, just moving it to the sides kind of thing, just to get you an idea. And this is the key point, just like the vertex, we'll just call it its starting points, okay? So we'll continue tomorrow. Hopefully this thing recorded, especially for those who having all those technical difficulties. Let me see.